Kennedy, and in this video, my group members and I would like to share with you the project that we worked on during our online internship with Bennett University. But first, I would like to express my gratitude to Bennett University for providing us with this opportunity that has been proven to be helpful in us learning and applying deep learning hands-on. I would also like to thank our mentor, Ms. Kanak Manjari, for helping us and guiding us through all the obstacles and hardships that we faced during the development of our project. An introduction of me and my group members. I am a third-year student at St. Kitts College of Engineering, Kottayam, Kerala. Kriti Singhal is a third-year student in Galgotia University. Mayank Garg is a student at IIT BHU. The title of the project that we worked on was Image Classification of Animals in the Indian Scenario using Deep Learning. Researches regarding animals in image processing have been a very important field to numerous applications. Identifying animal attributes, analyzing their behavior in pictures have been a very expensive and time-consuming task that is performed manually by various researchers. All this time and energy can be saved by using automatic machines such as computer. Thus, we demonstrate with our project that we can detect animals using deep convolutional neural networks. The project that was entrusted to us was to build an image classification model on the animals in the Indian scenario. The project involved training and modifying pre-trained deep convolutional network and also building a custom model to identify animals in a picture. Our project trains a deep learning model to identify animals from any picture that is given as an input.
Hello everyone, this is Mayank Garg. Now I will tell you about how we got the idea for this topic and about the problem statement. As we all of us know that in areas like an airport or the agricultural areas placed near the forest, many animals destroy the crops or even attack on people. Therefore, there is a need of system which detects the animal presence and gives warning about that in the view of safety purpose. Now coming to the problem statement, the biggest problem we have is our dataset that contained images of the animals that were in a more common circumstances, that is on streets, on roads, etc. The picture contained not only the animal that needed to be classified, but also other objects such as people, vehicle, buildings, etc. Usually when datasets are taken for research work, the pictures are taken more in the forest and in their natural habitat, which makes it easier for the model to train itself and to identify the animals as well. Thank you.
The classifier we built for a given problem statement executes itself in two stages, training and testing. The dataset consists of around 3,200 images of animals which are commonly found in our surroundings. The 6 classes of animals are cat, cow, dog, goat, horse and monkey. Now these images were not professionally taken and are unlikely to be in the natural habitat of the animals. Hence they provide a wider spectrum for a model to learn accurately. We performed the training of our model using two of the broad ways. First was using transfer learning. Now it is one of the most efficient and fastest way to train any classification model. We use 3 of the existing pre-trained networks, that is VGG16, VGG90 and Xception. The second way was to create our own model. We used our own sequence of layers and our own initialized weights. We changed these weights according to the result we received after each training, depending upon the issues of overfitting and underfitting. And until we removed these issues and received a good training accuracy, we performed the validation as well before going to the testing part. Now we will look into the result analysis using these 3 pre-trained networks and using our own model.
The result analysis can be summed up into 2 graphs. The first one is the loss graph. As you can see, we have pictorically represented the training and validation losses we got for the models we trained. None of the models we trained are overfitting because the validation loss was always lower than the training loss. Xception model has the least loss and hence is the best option among them. The second graph is the accuracy graph. This graph shows different accuracies we obtained after training each model. Our custom model also gave a fairly good accuracy of 84%, but the Xception model's accuracy was higher, making that the better model. Our custom model still performed up to standards by correctly predicting the answers.